second example, that is example 2.3, it states that consider the transformer in example 2.2, which I have solved in the previous lecture and in the previous video. Determine the voltage regulation in percent for the following load conditions. So our load is not the full load but 75% of the full load. And first we have a lagging power factor, then we will be having a leading power factor, and we have to draw the phasors. Okay, so in the previous example, if you can recall, we calculated these two circuits. High voltage reflected to the primary side. We calculated all the parameters for this one, and for the low voltage side, that was the secondary side. So for this example, let's consider the circuit that is referred to the primary, that is the high voltage side. This is not a fixed rule. You can also solve and you will get the similar results for the circuit referred to the secondary. But for this example, we are considering circuit reflected to the high voltage or the primary side. So this is the equivalent circuit. And let's first of all, it is a voltage regulation question. So this branch is of no use and we will ignore this branch. So if we delete this branch, this is our circuit, equivalent circuit of the transformer of example 2.2. So what do we have here? VH is actually the primary side voltage, and the value of this voltage is actually equals to the voltage drop across this, the voltage across this, and the voltage across drop across this. So for a transformer, and if we want it to operate on its rated conditions, and so the voltage should be 220 volts at the low side. So this will actually become, and this will be our reference signal, always that we have previously also shown. So this will be actually this voltage drop, that the output terminal of transformer will be, turns ratio for this transformer was 10. So again we have 2200 volts, and this will be our reference, the output signal. Secondly, let's look at the rated currents. So this was our transformer. Let's consider the high voltage side of the transformer. So VH equals to 2200 volts, and I rated will be S divided by VH. IH is NS is same. So this current will become, as we have calculated, 4.55 ampere. This was calculated in the previous example here, as I have calculated here. So 4.55. Now the load, if the load was full load condition or the rated condition, this would have been the current that is flowing through the transformer. But they have said it is 75%. So our current that should be flowing through the system will be 75% of 75% of 4.55 ampere, that is multiplied by 0.75, and this becomes 3.41 amperes. This is actually the IH. This will be the current. For this current we have to calculate. So the current that is flowing in this area, 75% of the total load, is actually 3.41 amperes. And the rest you know how to calculate. Okay, the next part is 0.6 power factor leading. We have the current, we have to calculate the angle for the current. And the angle for the current, we have power factor cos theta equals to 0.6. So theta will become 53.13. So one time we have a power factor of lagging, and the second time for the leading. For lagging, The current output of the transformer will be 3.41 ampere angle minus 53.13, and for the leading this will be 3.41 amperes plus 53.13. Okay, so now the rest is easy. Let's try to solve part A. And the part A says calculate the voltage regulation. Now, as I have told you, how much voltage we have to calculate this voltage. So the voltage formula for voltage regulation is, in this case, when reflected to that side, is VH minus V dash L divided by V dash L. So we have to calculate the value of VH for a fixed VL. V dash L, that is actually this value. So let's apply KVL here. V of H is actually equals to V dash L plus I dash L into R equivalent plus I dash L into JX equivalent high voltage side. So let's see, V dash L is 2200. This is our reference. I dash L we are considering for the lagging load. We have calculated, we have 3.41 ampere angle minus 53.13 multiply by R equivalent. What's the R equivalent here? We have calculated in the previous example. So it was 10.4 and 31.3 ohms. So here will be have 10.4 ohms. We have angle 0 because it is a resistor. And then we have again 3.41 ampere minus 53.13, and we have 31.3 angle plus 90, or this is actually J31.3. So when we solve this, the values that we will get after solving this will be 2200 plus 35.56, 35.46, angle will be minus 53.13, plus we will have 73, this is volts, and angle will be we can calculate as it will be 36.87 degrees. So actually in reality what has happened, this is VR and this is VX, and this is V dash L, that is the output of the transformer. So similarly, if we continue, we were in search of VH. So the value of VH will be 6.94, 0.9 degrees. So we can calculate voltage regulation here. Just the amplitude, you can enter the amplitudes of the voltages minus 2200 divided by 2200, and this, from where did I get 2200? This is actually AVS, or the low voltage side voltage. So the voltage regulation will become 4.86%. For what case? When we have a lagging power factor. And now if you want to draw the phasor for this, so the phasor can be, this is V dash L, then we have VR, it is at angle of minus 53, and this is actually VR, the angle here is minus 53, and then we have, I have to tail rule, this angle is actually 36.87. From the 0 it is 36 but it is 90 degrees from here, and this is actually VH, and this angle is 0.9 degrees. So this was Vx. So this is the phasor representation which is asked in part C of this. So this is actually this representation of this rule, and this is the phasor representation, and the voltage has to be larger than this for an inductive load. So now let's calculate for the part B. What is part B here? Part B is for a power factor leading, and for the power factor leading we know this is the current. So the rest is all is the same. The formula for voltage regulation is same as previously, VH minus V dash L over V dash L, and we know VH is equals to V dash L plus I dash L, R equivalent H plus I dash L, X equivalent H. But in this case, due to the leading power factor, the value of current has only changed. Here the current was minus, with the minus here it is 3.41 ampere plus 53.13, and the rest we know the values of this, and we solve the values, and finally what we will get, it is 2200 volts plus we have 35.46, angle is 53.13 plus 106.73, that is the inductor voltage, and the angle will be 143.13, and this actually becomes equals to, if you solve it, 2137.9 with an angle 2.48. So if you want to calculate this voltage regulation, this will become minus 2200, and the value of this is minus 2.82%. So the voltage regulation for this leading load is minus 2.82%. And let's try to draw the vectors for these, for this scenario. So we have our reference V dash L, that is 2200. Then we have an angle 53.13. It will not go downwards, it is a positive angle, so it will be like this, right? 53.13. From here the other angle, that is 90 to this, belongs to Vx, this was VR, and this is then VH, You can change its color also. This is actually VH, and this angle is 2.48 degrees. So this is how we have calculated the phasor also. I hope it helps.